So hello everyone again. Today I'm going to present about this new project, and I hope you understand what was my reasoning to start with this new project called ECA, which stands for Editor Code Assistant. And I will try to show some of the features, and how to get started with this new tool. And I will try to show what is called the LLM loop, which is how it was something that was pretty mind-blowing to me when I was implementing ECA, and how this works together with the LLM to make multiple calls and things that you see on this GIF. So feel free to interrupt me, Bruno, if there is some kind of question or relevant to the chat. And let's start with the rationale. So what was the reason for me to start with this project? So as you know, that I'm Emacs user, so I use a lot of Emacs. I do have some experience with VS Code, IntelliJ, and other editors, but I use Emacs for mainly every language and everything that I do related to coding. And I was trying to, like I mentioned, I was trying to avoid the AI word until I realized that I was already using daily on my code. I was just copying and pasting to GPT or something like that. So I realized that I needed a good tool. And some months ago, I started to researching, and I found either Emacs, Cloud Code, LL, and other like Amigo and some other alternatives. And I was just not happy with the user experience and the integration. And meanwhile, the other editors had a lot of options and good UX. And I started to wonder why we don't have a standard for those things, why we don't have a way to code in a single place and be available to multiple editors. Does that sound familiar for you? Which is the same thing we have for programming languages, which is the LSP, right? So the LSP, for those who don't know, is basically a protocol that Microsoft created when creating VS Code, because they were just not in the mood to re-implement all the features that we had for IntelliJ and other editors again. So they found out that having a single way to define Clojure, we could leverage this in multiple editors. So this was a standard that is a success nowadays. So every editor supports LSP, and it works really well. I'm the maintainer of Clojure-lsp, so I went into this world and I understand how those things connect, like the editors connecting to a server. And this made me realize that we didn't have anything like that for AI, but it makes a lot of sense to have something like that, because are just more features related to AI coding, and it would be really nice to have everything in a single place, So what I saw was that there was a lot of AI alternatives in multiple editors, but they just supported one editor or two, and they were just different and were missing features and things like that. So that's why I thought maybe we could have a single way to have those things. So for example, you can see that I'm showing the demo of ECA Emacs and ECA VS Code, and they just look pretty similar, like the same UX interface, the same things available, the same features, and all of that is using a basis server, right? So this is basically how ECA works, and the good thing about it is that it just server in the middle of editors and the LLMs. So it can provide a lot of features about chat completion and things like that. So the editors can request those things, and ECA can just have all the ECA server can have all the logic to delegate to the LLMs. And some of you may ask, like, why not use LSP for that? And the problem is the LSP is pretty much generic. So as a maintainer of ClojureLSP, I noticed multiple times that we needed to add some kind of features, and the LSP protocol didn't provide that. So it does have like a way to extend with more features, but then it is just not related to the protocol. So to have things like chat and AI completion and things like that, it will be pretty different from the LSP, and no other like editor would support that. So a protocol specific for AI probably is more assertive and more direct to the point. All right, so why I chose Clojure for that? So that's a question some of people ask to me. So as you know, AI in the AI world, Python and now TypeScript is used a lot, and I chose Clojure for a reason. The first thing is my experience with ClojureLSP and the base of ClojureLSP, which is the LSP for CLJ. Like I'm coding those tools for a long time, and I know how those things connect and how to create those kind of things. So it was pretty easy to set up ECA with those kind of basic things. Like in a single day, I already had like the server running with no features, but like all the complex stuff related to messaging, like communicating with the server, was pretty straightforward. So how this works is pretty much the same for LSP. So it's the server that is a process that runs on your machine, and the client connects. The client is the editor in this case, and connects with it, sending JSON RPC messages through STDI, standard in and standard out. So this was pretty simple because I already had all that knowledge about setting up those things. I also had knowledge about GraalVM because ClojureLSP is compiled with GraalVM, so it was pretty simple to make make ECA be compiled with GraalVM. So it's pretty fast to start the ECA server, and I also had knowledge that memory and CPU performance is increased with GraalVM after all those years using ClojureLSP. So it was a good decision, and it helps with the fact that JVM is slow to start most of the time compared with other tools. So this helped a lot and made a lot of sense. Also, the async stuff is just easier to manage. So there's a lot of async happening in ECA related to receiving messages, calling the LLM, and handle the loopy and things like that. So since this is done in Clojure, it was pretty simple to handle all those things with threads and just features like we do with Clojure. And I was seeing like a lot of Python tooling had issues with that, and TypeScript user as well. So it was that was something that I found that using Clojure helped a lot. And this one is a little bit my personal, but I just ship faster with Clojure. Like I've been using Clojure for a long time, and I just ship things faster because I just have the knowledge about the language. So it's a personal decision of mine that helped a lot. So this is the rationale. I don't know if you have any question related to that, but otherwise we can start checking the getting started and how ECA works. Okay, so let's start with how we install ECA. So as I mentioned, there are editors that need this kind of protocol support, so there is no way to run from that. But the amount of code that needs to be done on those editors is way less than the server itself. Like the server has all the logic to connect with LLMs, and multiple times I improved the server a lot, and the editors just get those things for free. So what we have on the editor side is basically like how to download the server, start it, like how to receive and send messages and plot on the chat, or provide features or like editor things. So this is just basic stuff. I mainly have Emacs like with all the latest features. So ECA Emacs is like at the moment, in my opinion, is like the best alternative for AI development with Emacs. It just have like a good UX with multiple options to toggle, disable, configure chat, windows, and things like that. So it's a nice thing. So you just install that like as a normal plugin or extension for your editor, like VS Code and things like that. After that, you like open ECA and you need just to configure your model. So there are multiple built-in models like OpenAI, Anthropic, or Llama models, and there are ways to configure like custom providers. For example, checking the documentation, you can, for example, have your company's provider with like the URL and the key and the models that provider supports. And after that, you are good to go. You can like start using its features. So I will try to show some of them. So let's try to show. I have like a working project here is ECA itself, which is written in Clojure. So let's start ECA. So I started. You can see that it's already running. It already noticed that the server is downloaded, started with GraalVM, so it was pretty fast. And then we have like the chat window here with multiple options. So for example, I have options to select the model. I can just click and select different models. I have a custom provider from my company, which is Nubank. So if we go to the, let me check here. If we go to the configuration from ECA, which is on my home config ECA config JSON, we have like configurations for Nubank providers, so like using its credentials and things like that. And I already have it running. It has the behavior. So behavior is basically how the LLM should behave, like what kind of mode it's using. So there are two behaviors right now, which is the plan and the agent one. So the agent is like, just do the stuff, what I asked, like change files, grep for things, while plan mode is more like, do your research and just output to me what you're gonna change. And we have like options for MCP. So we can see like all the MCPs, and you notice that ECA has like built-in MCP, like built-in tools that it provides to the LLM. So that's basically how tools like Cloud and Cursor works. They like are clients from the LLM API, but they provide like built-in tools. So tools to like check what a director has, or write files, edit files, move files, and things like that, grep for searching. And we could have like a lot of other MCPs. I just have Clojure MCP running here, and I don't know why it stopped, but I restart. And then I can just go back to the chat. You see that it's starting. And from here, you can just chat with AI like normally. You notice some things like, for example, we have this @ symbols, and they stand by the context. So beside the tools that which are on the documentation, you have like the context, which are things that you can add to the LLM to have like a clear, all the LLM communication, it's based on context. So the better the context that LLM has, the best will be the result and the output quality. So you could, for example, just remove the file that is loaded here, and it will know that needs to like search for something. So for example, I can try ask, what is the tokens cost function. So it does have like the repo map, which is basically a list of files from the project and things like that. So, but let's try to use it knowledge to find this function. But we could just, for example, query here and just add the function that we know. So we can see that it's calling MCP2. We can expand to see. We can see that ask it for, it's trying to search for the function using the pattern, and the output was 3 files that had that function, probably like the definition and the colors. So it started to reading those files using Clojure MCP, and then it found that it's defined here. So in the end, the context is the important part for the LLM, and it's good to provide the context, but it doesn't mean the LLM can't find those things, because it has the tools to find, but the best is always to provide the context that you are editing. So when you have like empty conversation, you notice that automatically you add like the file that you are here. So for example, if I go to shared text, you notice that the chat will update. So you can always query those things. So for example, I want to add like, I don't know, the README about the project or some other kind of, I don't know, the shared file. So you can add things like that. And you can actually like add other things. For example, we can have the MCP resources, which are the, but basically a feature from it that MCPs could provide, and ClojureMSP provide like some of them, which are like contexts that it could be provided to the LLM, and it's built in on the MCP. So ClojureMSP has some of them, and you can just use like that. So this is one of the features. And you have also, what else? There is a agent MD, so we can just try to, let me explain this one first. So besides the prompt that you can send, you can like type / and complete with commands. So you have like built-in commands, which are the ones from ECA, but you have also the MCP prompts, which like, it's like the resources, but are texts that were provided by Clojure MCP. So for example, all of that, those are provided by Clojure MCP, and prompts are basically like a bunch of text that's shipped built in the MCP. So for example, there are system commands. For example, I want to check how much the cost of this chat. I just erase it, so it's empty. I can, for example, let me check the repo map. So the repo map is like a context that we send to the LLM. So we can see like all the files in the project. Let's see, for example, this one is pretty useful, like the prompt show. So the prompt show is exactly the input that we pass to the LLM. So you see like a lot of things, and like the basic template for ECA, which is like it's saying to the LLM that you are ECA and should help with AI code assistant methods. You are programming with the user and things like that. When communicating in Markdown mode. When edit files, do things like this and like that. When calling to calls, do things like that. We have like rule supports and the context. So you saw that we included a context about the, there is this context which is included automatically, which is the agent MD, which is basically a file with a Markdown file explaining the LLM how it works. It's something that people just version on the project root itself. And we have like the repo map context explaining all of that I mentioned. So this is like the whole prompt that goes to the AI. So when we are talking with AI, it's just using that to find your code. So for example, let's try something here, which is, for example, I think that this function, I don't have unit tests, my bad for that. So let's try to all add for them. So add unit tests for tokens to cost function. Okay. Let's try something different. Let's start with using clojure-MCP to see how good it is, and we can try to disable and use it like ECA built-in function. So it's just, I'm using GPT-5 here, so we can have like defaults. So all the reasoning that the LLM uses to take these actions, and it's used to debug. We can see that it's like reading the tests for this namespace first. It's then like reading the test helper to understand, reading other files, and like we have like the edits that gonna be changed, and now it's calling another MCP tool, which is the file edit. We can like see outputting the text that's gonna be edited, and this is it's waiting for me to approve or reject this call. So this is a configuration I have like on my config.json saying that I want to manually approve those functions. So I can just check it like, oh, okay, it's just changing all those things, and I can just accept it. Then there is a error because the file it was outdated from the repo. So it's asking to read the file again, because the read file from the Clojure MCP, it's not just read the content, it changed the repo state, so it knows what is the current state of those functional definition in the repo. So it reads again, and now it's trying to do the change. Oh, it doesn't work again because the shared test is another file that needs to be read. So let's try again. Then a file write. Yeah, for some reason, Clojure MCP is not able to read. I don't know if it's related with my repo session. So let's try to, I don't know, I will evaluate the file again. Don't know if that will help. Yeah, now it worked. So there was some kind of issue with the repo state I had here. And now we have like the file with the new test. So we can see like we have the tokens. You notice that the LLM is like following the standards of the project, like a single dev test with multiple testings. It's like the standard of the project. It already noticed I'm using Babashka to run the unit test. So it runs and it just worked like from the first time. It's just like created the test with all the cases. There is instructions to like do this commit, but I just stop it because I don't want to commit it right now. But this is like how it works, and you can use like the plan behavior to just ask to the things first. So let's try to use disable Clojure MCP and do the same thing. Like I will remove this test that it created. I will start a new chat session, and we will try the same thing. So let's create a test for tokens to cost function. And this time I will not provide any context, so it will need to like grab and find the function by itself. So it's listing like the files in the project root. So, and now it's searching. We can see like the string is way better because it's using like the ECA native tools and not the MCP1. So it's easier to like understand what it's doing. Now it probably is gonna read a lot of other files because they are just related one to the other. And then since it's on the plan mode, it probably asks for my permission. Meanwhile, we can see like the costs down here, which is related to like the last message cost and the total message cost. And while it's doing its work, let's check other features. So like I mentioned about the comments, and you can actually have like custom comments, which is a pretty nice feature. So let me open just another chat section on the ECA VS Code, and you can see that I have like optimize and explain tags. So those are just custom comments that I created. So if I go to my config, you can like have a comments folder, and you see the explain tag, which is just a prompt that is tell me what the tag arg1 of this project did. So arg1 is the argument provided by the user. So we can just then explain tag. I think, I'm not sure if we have tags for this, but let's try. Let me check what are the tags for ECA VS Code, because I don't even know if we're using tags. Okay, so we have like, for example, explain tag 0.001, and it will just like start to issue comments to find that. So this is how custom comments work. And it's pretty useful to have like comments for links and tasks and things like that. Meanwhile, like in the other chat, we had like a plan. So we can see that we have like a nicer view for shared test, which is like the diff that it's trying to do. So I can just go to the file and like check the diff. We have like, for example, the diff using basically the diff of Git, and I can just I think it's this one. Oops, I think it's this one. Okay, so I just applied the diff, and now we have like everything working, and it's pretty much the same, a similar function from Clojure-MCP. So you can see, like Bruno, you mentioned about the other languages being trained better. GPT-5 is already way better than previous models, so we can see that this is a kind of simple function, but it shows how like it didn't have any issues with parentheses and things like that, and it's following like the standards and pretty much similar to the other functions. So we can see like the models they are way better than before. I think that's it about the ECA itself, and I can show how the LLM loop works. Like when you are asking to do things, how those things work with it. It's kind of mind blowing, like calling tools and doing stuff. So let's try with something simple here. Let's try to, let me first check the debug logs so I can show to you how those things work. So I will actually stop that and restart to have a clean session. So let's start with something simple, like what files you see. So when we ask that, if we go to the Clojure code of that, we will see a lot of things, but let's try to focus on the important part, which is like the prompt message that we're gonna send to the LLM. So we have like a common API, and we are saying to complete those things, and we have like basically some kind of condes and switch cases to see which is the provider, like if it's a custom provider, if it's like a Llama 1. So we know that this is gonna go through OpenAI. And the cool thing about it's just a request, HTTP request, using a normal library. And the fun thing about this is when we mention, let's try this, like when we send this, so this is like the output. We can see like the LLM responding. So we're streaming. So we are using like server sent events, and we have like the TOFs part and the list file and like all those things. And you can see that those kinds are always streamed. For example, check it out, like the arguments of the function. So when we open this, we can see like arguments, path, and things like that. All those things are streamed, so by parts. And we just build like the final response. And this works for reasoning and for text as well. So you can see like all the text like OpenAI chat if you want me to drill into any specific directory. So all those things are streamed. And so this is the response, and this is the body that we are sending. So when we send the body, we pass like the tools that we have. So you can see like a lot of tools, and we can just copy those tools, open a new buffer, and let me try to show it. So actually just format this better. Okay, so those are all the tools that we're passing, and like the description of the tool, the parameters that the LLM should know about. So for example, let's get this one. So ECA director tree, we are describing about this tool. We are saying that it returns a tree view, and it should be specified from a path. So the path is required, and there is a description. So the LLM knows about this tool, and it knows that should call this tool, right? Because of the description of this tool. And it knows like how to structure this tool call. So when it notices something like that, in the response, we will see something, okay, I will try to call a tool. So I'm doing a request to the LLM, and it's streaming those kind of arguments, and in the end it just finished the request. It ends with something like, okay, I'm finished, and the response of this is a tool call, which it should be something, let me try to find it. Yeah, like right here. So it's a response of type function call, it's completed, and the arguments of this call should be this one. So at this point, this request right here is finished. So ECA received this finished request, but it knows it's related to a tool. So what we did, we call this tool. So in this case, it's just basically, if we go to the file system, we'll see like all the file system related tooling that we pass, and we'll see like director tree, and the handler function, which is like what we're going to do is basically just using Babashka file system to like list the files and directors from this path and output again to the LLM. So what is this output? We just send, we can see that we are calling the tool, and then we get the result, like the content, and then we basically just send the request again to the LLM. So this is what it's called LLM loop. We just append to the message. So those are all the methods that we send. So we are always like accumulate the whole history and conversation and send all those messages again for the context to the LLM. So the first message, like user asking what files you see, and then we see like the reasoning block, which has an ID to the LLM to understand what was its top. Then we can see like we have a function call, like the function, the arguments, and then the function call output. So we have like the response, and this is sent right here. So at this point, the LLM like it's reasoning again. It just thinking, oh, okay, like I asked it to list a call, I received the output, and what I should do right now. So it just realized that should list other files. So it's trying to list more files under source directory or under the LLM providers. So, and this is just a loop. So it's calling again, and then it has like all the context that it needs to like output to the user what it found. So this is what it's called LLM loop, and what is mind-blowing about it. Like, you have like a loop of interaction, and this is why some models become way expensive, because when you chat with, for example, Claude, and you ask to do something, and it like doing a lot of tool calling, it's basically like just sending a lot of messages. So it was not just a simple prompt. It's like a lot of interactions happening. So this is what it's called LLM loop. Any questions so far?
No, there is no questions.
Okay, so I think my idea of what it works is like that. So VS Code is just like the same thing. You have like the context, you have like the same user experience from VS Code. You have like the thinking blocks and things like that, and all the tool callings. And the future of the project is, I intend to add a lot of features. So that idea is to add rooks and a lot of things that Claude has. My idea is to like make as good as Claude and Cursor. I feel like it's pretty close to Cursor nowadays and pretty close to Claude. So you should give it a try. I'm really open to feedbacks and help, so I want to leverage this and become a really great feature. I'm working on support for IntelliJ right now, so soon we should have like all the major editors supporting ECA. And so there are more people helping, supporting more models and flags and settings. And I think that's it. I don't know if you want to check anything specific right now, but that's my idea. So please check it out, the project on eca.dev or the GitHub project, which is Editor Code Assistant ECA.